Hey guys, we're back with the notes for 6.1. We're going to be talking about the laws of exponents today. Basically, these are the rules that let us know what to do with the numbers, which are called the base, versus the exponents, which are the powers. Okay, so just a little bit of vocab. I want to make sure we're all on the same page. When you see a number like 2 to the third power, what that means is this is the base. This is your what. This tells you what you are multiplying. This number up here, this is your power or your exponent. This tells you how many times you're multiplying it. So when we say 2 to the third power, we mean our what multiplied how many times. So 2 to the third power, you're going to use that 3 times. Okay? Just so that we're all on the same page, let's go ahead and look at the rules. Our first rule is the product of powers. Go ahead and pause the screen, write what you see, and then we'll get started. Wonderful. Okay, so when we talk about the product of powers, basically the coefficients, which are the big base numbers, those are going to follow the normal rules, which is multiplication. The exponents or the powers, those are going to add together. We're saying how many and how many more, how many total. Okay, so for instance, on problem 1, my base number is a 2. I'm going to think about those going together. Okay, so I have how many 2's to start? There's 3 here. How many more 2's? 2 more. How many total 2's? That's going to be 5. I'm adding them together. Okay. When it comes time to expand this, to simplify this, we want to make sure that we are multiplying any number with an exponent all the way out. So if I type in my calculator, 2 raised to the 5th power, my final answer on this problem is going to be 32. Okay? Whenever you have a number raised to an exponent, we want to simplify it all the way out. Okay? All right, let's talk about number 2. My base is a W. So what am I multiplying? I'm dealing with W's. Then I ask myself, how many W's are there? Well, there's 3 in the first part, 4 in the second part. That gives me a total of 7 W's. So W to the 7th power. Now, problem number 3 looks a little bit different. It's okay that there is no multiplication dot because we know that parentheses still means to multiply. So with that being said, I don't have an exponent on my 5. I also don't have an exponent on my 2, which means that I'm going to follow the normal rules and multiply them together. 5 times 2 makes 10. After that, now I can worry about my exponents. How many total x's do I have? I have 4 in the first parentheses, 2 in the second. Add that together makes a total of x to the 6th. For the y's, I don't have an exponent on either one because it's really just one y on each parenthesis. Y to the first power, y to the first power. If I add that together, I have a total of y to the second. Okay, take a second, write that down if you need to. We're going to go to number 4. Problem 4, the 2 and the 7 do not have exponents, so we follow normal multiplication rules with them. 2 times 7 makes 14. The W's do have exponents. So W, I need to know how many total exponents there are. 5 W's on the first section, 11 on the second. That makes W to the 16th. I add them together to make the total. Okay? I want you guys to take a couple seconds, go ahead and try number 5 on your own, and then we'll check your answer. Go ahead, try it. Okay. Your answer to start should be 15. We're multiplying the 3 and the 5 just like normal. We count up how many x's we have. That's x to the 5th. There's a 1x on this side. And our last part is y to the 7th. Remember, you have 1 power for your y on the first parentheses, 6 on the second one. That makes a total of 7. If you missed anything in the power section, go ahead and write it down. We're moving down to the power of a power. Okay, pause the screen, write what you see for just a second, and then we'll get started. All right, on this section, What do the exponents do when they're outside of a parentheses? You need to know two main things. You need to know that those numbers distribute. Just like any number outside of a parentheses, they need to travel to each base or each part of that problem, each part of that parenthesis. Second thing you need to know is that when they get there, they multiply with the current exponent. Okay, they multiply with the exponent that's already there. So it's important that we know what that number is. Okay, let's go ahead and look at number 6. If I distribute that 4 that's on the outside in to the other exponent, I'm going to multiply when it gets there. So my base is still an x, but I'm multiplying. 2 times 4 makes 8. That's my final answer. It kind of really means that I have 4 sets of x squared. If this is an easier way for you to think about it, that's fine. You don't have to write it down. But it's saying I have 4 sets of 2. So 2, 4, 6, 8 total. Okay, let me erase that. Let's try the next one. The next one says I have 5 sets of 2. Okay, so I'm going to distribute the 5 into the base. And when I get there, he's going to multiply with the exponent that's already there. So 2 times 5 makes 10. And remember that when we have a number with a base, a number with an exponent, we do want to multiply that out. When you do that, your final number should be 1024. Again, you would write that as 2 raised to the 10th power. All right, problem number 8 is the first time that we have several bases. So here's what I'm going to do. I want to kind of color code these so that you can see the difference. So we have a 3, we have an x, and we have a y. So I'm going to distribute the 4 to all of the bases. When I do that, I end up with 3 to the 4th power. That 4 is coming over and it's becoming the exponent for 3 because 3 didn't have one yet. Or you could say his exponent was a 1. That 4 comes in and it multiplies with the exponent on the x, which is 3. 3 times 4 makes me a 12. And the 4 comes in and multiplies with the exponent on the y. That exponent isn't there, so it's just a 1. 4 times 1 makes 4. Okay? Now, because my 3 still has a number with an exponent, we are going to simplify that one step further. So if I go ahead and I do 3 to the 4th power, we get 81. Oops. We get 81, and then we can keep the rest of the numbers to the 12th and to the 4th. Okay, let's do the same thing on problem 9. Problem 9, I'm going to distribute the 3 into all of my bases. Remember, I have a base of 5 and a base of x. The 5 does not have an exponent right now, so he is going to take the 3 as his exponent. If it's easier for you to think about the multiplication, you could say 5 to the 1st power, and then 3 times 1 is 3. Okay? I'm going to distribute the 3 into the x's exponent, which is 6. 6 times 3 is 18. I am not allowed to leave this 5 to the 3rd. I have to simplify it one step farther. So 5 to the 3rd is 125. We're going to write out 125 x to the 18th. That's his final answer. Okay. If you need to pause the screen, write what you see for just a second. We're going to wrap up 10 and 11. Perfect. So last two over here, these are fractions. The rules are the same. We're going to distribute the number on the outside to all of the bases on the inside. So I'm going to still use x's are yellow. We're going to use y's are black. Okay. So the 3 is going to multiply with all of the bases. The 4 does not have an exponent, so he is going to take the 3. The y already has an exponent, so they are going to multiply. When I do that, I end up with 6 as my exponent. 2 times 3 made 6. Now, I can't leave that 4 to the 3rd power. That's not simplified. So I'm going to go ahead and write it out. 4 raised to the 3rd power, like this, is going to give me 64. So 64 divided by y to the 6th. That's my final answer. Last one. 2 is going to distribute to all the bases, the 3, the x, and the y, and he's going to multiply with their exponents. So if I do that, I have 3 to the 2nd power, x to the 8th power, that's the 4 times 2, and y to the 2nd power. Mainly because he didn't have an exponent, he just takes that 2 and it makes it his exponent. 3 squared cannot be left like that. We know 3 times 3 is 9, so I'm going to simplify my answer. 9 x to the 8th divided by y squared. That's a full answer. Pause it, write down whatever you missed. We're going on to the next page. All right, there's quite a bit to write down on the top of this section, so I'm going to give you a second, pause the screen, write what you need, and then we'll get started. Wonderful. So when we look at this problem, quotient of powers, negative powers, and zero powers, they all have to do with coming out of a fraction base, okay? So first question, what would I do for numbers if they're on the top and the bottom of a fraction? These are regular numbers. Okay, so that's going to apply to problems like, let me see if I can highlight, questions like number 7, where you have a negative 18 and a 6. What are we going to do with those numbers? Same thing like on number 2. I have a 10 and a 2, or a 15 over 6, or a 3. Anytime you have those numbers on top and bottom, we're going to treat that like a regular fraction. We're going to divide them. They follow the normal rules. Okay, so let's go through and let's do those ones first. Okay, on number 2, if I simplify that, I end up with 5. On number 3, if I simplify that, I end up with a fraction still. 15 over 6 can simplify. They're both divisible by 3, so I would get 5 over 2. Problem 4 wouldn't divide. 3 over nothing is just 3. Okay, there's an imaginary 1 there. Number 7, negative 18 divided by 6 is a negative 3. Okay, nothing is changing about that rule. You're just dividing like normal. Okay, let's talk about the next part. What do I do if there are the same variables on the top and the bottom? Okay, when it comes to that situation for the variables, we're going to ask ourselves who has more. Does the top have more or does the bottom have more? Whichever side has more, we're going to subtract the exponents and we're going to write the remainder on it, okay? So let's go ahead and look at these. Let's say I'm looking at problem 1. Problem 1, I have A's on the top, A's on the bottom. So I would ask you, who has more A's? The top does. So I'm going to write my fraction, and I'm going to say there's more A's on the top. How many more A's? Well, 6 minus 2 makes 4. So my remainder is that 4 on top. Let's change the color. What about for B's? Who has more B's? Well, the top does. So B goes on top. How many more B's do I have? 4 minus 3 leaves me just 1. And we don't usually write an exponent of 1, so we would just leave it for A to the 4th B. Now, there's nothing left on bottom. So we can either put a 1, like a placeholder, or we can simplify that and just write the whole number. A to the 4th and B. That's your final answer. Let's try another one like that. All right, so on problem 2, we have T's on top and bottom, and we have D's. So let's start with D. Who has more D's, top or bottom? The top. So I'm going to think about putting D on top. How many more does it have? 5 minus 4 makes 1. We don't really need the 1 exponent, so I'm going to take that off. Who has more T's, top or bottom? The top. How many more? 3. Take off this 1 or subtract by 1, leaves us 2 left over. There is nothing left on bottom, so we would keep a 1 for a placeholder, and then we would simplify to our final answer. 5DT squared. Okay, let's go ahead and try number 3. Number 3 has x's and y's. We would ask ourselves, who has more x's, top or the bottom? Well, they're both the same. So if I think about subtracting them, x to the 5th, x to the 5th, subtract the 5's, that gives me 0. So that brings us to our next question. I'm going to look at this one right here. What do I do for a 0 exponent? Okay, well, if there's 0 x's, that means there's nothing there. We're going to ignore that completely. I don't need to write down any x's. You can think about it like they canceled off. Okay? Finishing up with that problem number 3, we'd say, well, who has more y's, top or bottom? The bottom has more y's this time. So I would keep 7 minus 3 makes a 4. There are 4 left over on the bottom. So my final answer actually looks like this. Oops. 5 over 2y to the 4th. I don't have anything left to simplify. That's my final answer. I'm going to center it just a little bit. There we go. Okay. All right, let's try number 4. Number 4, we have x's and y's again. So which has more x's, top or bottom? The top does. Remember that there's still a 3 on top. We didn't divide him. There's more x's on top. 10 minus 8 gives me 2 x's left over on top. Who has more y's? The top. 11 minus this 1 on bottom makes 10. There's nothing left on the bottom, which means we put a 1 for a placeholder, and then we simplify. 3x to the 2nd power, y to the 10th. Okay? So the only time you have to simplify, let me kind of zoom over here. The only time you have to simplify is if you have a number raised to a number, then you should give a final answer. Or if you have, let's say, blah, 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 answer over 1. You would simplify that and take out the 1. It'd be the same as you giving me an answer that said 2 over 1. No, we would just say 2 as a final answer. Okay? All right, so let's look at number 5. We did not talk about number 5 for the simplifying. What would you do with 14 over 10? You type it in a calculator, see what it simplifies to. That would give us 7 over 5. So let's look back at our A's. Who has more A's, top or bottom? The bottom. How many more A's are on bottom? 7 minus 2 makes 5. But then I look at the B's, and I get very confused because we haven't talked about negatives yet. Okay, so I'm going to go back up here to our steps, and I'm going to look at this one. What do you do when you see a negative exponent? The directions say you need to change levels and make it positive. Let me show you what that means. That exponent does not want to be where he is. Okay? This B does not want to be on the bottom floor. So what we're going to do is we're going to get rid of him. I'm going to grab black pen. We are going to change his level and change the exponent to a positive. Okay? So all we did was cross him off, change his level, and change him to a positive exponent. Okay? Now when I ask you this question, we don't have x's on top and bottom. We're not subtracting anymore. Now I would just ask you and say, how many total b's do we have? This is the very first thing we talked about. I have 4 b's on the first part and 3 b's on the next one. That gives me a total of b to the 7th. There are 7 b's in my problem. Okay? Final answer, 7b to the 7th divided by 5a to the 5th. Okay? All right, I'm going to skip number 6 for just a second. Let's finish out 7, 8, and 9 real quick. Okay, problem 7. I'm going to go ahead and highlight these. We got W's on top and bottom. And we have M's on top and bottom. So let's start with M's. Let's just go alphabetically. Who has more M's? The top, right? 9 minus 2 makes 7. So I'm going to have 7 M's left over on the top. Top and bottom both have W's. Which side has more? The top. 5 minus the 1 W on bottom gives us 4. And there's a placeholder of a 1 on the bottom. I don't want the placeholder, so I'm going to go ahead and simplify. Negative 3, M to the 7th, W to the 4. Problems like this, it's very important that you make sure you don't just line up and subtract the numbers. The W's were not in order and neither were the M's. So make sure you match up the bases. Okay? All right, number 8. Right away I look at that and I notice that the A on the bottom is a negative exponent. So I'm going to cross him off and I'm going to change his level, make him positive. Then I ask myself, how many total A's are there? There's 12. Where are they? They're on the top. A to the 12th. 5 plus 7 made 12. Who has more B's, top or bottom? The top. How many more are up there? 4 minus 3 makes 1. We do not use a 1 for an exponent, so we take that off. There's nothing left on the bottom, so we use a 1 as a placeholder. I don't want a placeholder in my final answer on the bottom, so we're going to do A to the 12th and then a B. Okay? Let's try one more like this. On problem 9, I have X's on top and bottom. Who has more X's? Neither, because 3 minus 3 is 0, and these cancel. I only have Y's on the bottom, so there's nothing that I can do with them. There's nothing to add to, nothing to multiply, nothing. But there's nothing on the top at all. I need a placeholder here. And I need to put that 1 up there to keep it. I'm going to zoom out for just a second. Okay, this is like giving an answer of 1 over 2. You cannot just give 2 as an answer. Those are not the same thing. Okay? When you have a 1 on top of a placeholder, that is your answer. There's nothing else that you can do to simplify it. So same thing here. If you finish a problem and the 1 is on top, that is your final step. You cannot do anything with that y to the 5th and move it around. Okay? All right. If you need to pause for just a second and copy any of that, go ahead and do that right now. Otherwise, we're going to finish up these last 3 problems. Okay? All right, on problem number 6, give me just a second to get it highlighted. All right, my first base is a 3, my second base is an X, and I have a number on the outside. Remember that means we're distributing in to the parentheses, and we're going to multiply the exponents. So the first thing I notice is 3 doesn't have 1, so he keeps the negative 2. Second thing I notice is that the 5 is already there, so negative 2 times 5 is a negative 10. All right, so if I'm looking at this problem right now, and I notice that the negative exponents don't want to be where they are. Right now, they're just in the regular top part of a fraction. Remember, technically, this problem is over 1. So here's what we're going to do. I'm going to use red this time. We're going to cross off anything with a negative exponent, change its level, and make the exponent positive. So same thing. Take out the guy with the negative exponent, change his level, and make his exponent positive. So now when I do this, there's nothing left on the top. I put a 1 for a placeholder. On the bottom, I have a 3 to the 2nd power and an x to the 10th power. Now, right here, I still have a number with an exponent, which means I have to simplify this one more time. 3 squared is 9, so I'm putting 9, x to the 10th on the bottom. The 1 placeholder stays on the top. Your answer on a quiz is not correct until you get to here. Okay? All right. The last 2 questions, I'm going to use back up here for our reference answers. What do I do if I have a 0 exponent on the outside of my parentheses? These are my favorite questions. You don't have to do any work. If I distributed all of this, and I did 2 to the 0, x to the 0, y to the 0, what I'm telling you is there's nothing there, okay? There's no pieces in this problem. So what we do from the very beginning is we just put our placeholder. You could think about it like a fraction, 1 over 1. There's nothing on top, nothing on bottom, nothing there. Or you could just write 1, okay? It's just a placeholder. Same thing on that next problem. 4, a to the 5th, b to the 2nd, all raised to the 0 power. There is nothing. There's no 4s, no a's, no b's. All I need is 1 placeholder. My answer is 1. Okay? There's nothing I can do to simplify that. It just is 1. Okay? All right. Your assignment is the next pages that say 6.1 practice. We do have a quiz over this topic, so if you have any questions, be sure to come see me in tutorials. I'd be happy to answer any of those. Have a good afternoon.